The argument of a complex number. The argument of a complex number is the angle that a vector joining the origin to the number makes with the positive real axis. So if we have the complex number z is a plus bi, so that's the vector representing it in the Argon diagram. It's a units across, b units up, and this is a right angle. And this time what we're interested in is the angle that this vector makes with the positive real axis. The argument may be given in degrees or radians, but radians is more usual at this level. The principal argument is normally given in the range between negative 180 and 180. Notice how negative 180 is not included, but 180 is included. Or in radians, of course, that's negative pi to pi. Note, there are two functions, arg with a small a and arg with a big A. Argz is given in a range as above. So arg with a little a is the principal argument of the complex number. Arg with a big A is a general angle, so potentially that could go from negative infinity to infinity. You are unlikely to see arg with a capital A referred to, but we do make use of it when finding roots of complex numbers, as we'll see later on. Suppose in the diagram that theta is pi by 6 radians, or 30 degrees. So that would be the principal argument of this complex number. Then argz, the principal argument, is pi by 6, but argz with the big A is pi by 6 plus 2n pi, where n is an integer. So it's not just the pi by 6, but every time you go around, no matter how many times, and land back on that point. Note, one must be careful when working out the argument. We cannot simply use theta is the inverse tan of y over x, as the period of the tangent function is pi, and the calculation above will always return theta in the range from negative pi by 2 to pi by 2. So it's only going to give us an angle in quadrants 1 and 4. And of course our complex numbers can be in any of the 4 quadrants. So it's always best to sketch to make sure we get the correct angle.